Hello, and welcome to the third evolution simulator video. In the previous part, I noticed from the graph on the right that the system was relatively diverse. This is weird because the system is relatively simple. Upon further inspection, I realized that the old simulation had a really high rate of evolution. In this simulation which you're watching now, I've turned the rate of evolution way down, which has resulted in a much smaller area being covered on the graph. However, the increased specificity of the system comes at the cost of time. Because it evolves at a much slower rate, it takes a lot longer to reach its optimal level. For this reason, I've sped up the footage a lot. Just like in the previous simulation, what we can see is the mass in the graph is slowly moving upwards and to the left, representing an increase in attack and a decrease in reproducibility. The graph is also becoming more red over time. Let's see what happens when we add back the cheese grater pattern, creating two different environments. Gradually, over time, what we see is the single blob representing the entire system is shifting into two blobs for the two different environments. This is the same thing that happened in the previous video. However, we can see the split much more clearly because of the increased precision of the model. Weirdly, the blobs don't always stay separate. Sometimes they mingle with each other. I believe this is caused by the interplay between the two species. Sometimes the red species from the bottom shift upwards, and sometimes the blue ones from the top shift downwards. However, they never stay in that area because they're not suited to it. I found this intermingling really visually interesting, so I wondered what would happen if I sort of created a separate species to live in the same simulation as my regular trees. To create this new species of tree, I gave an attack bonus to the 5% of trees with the highest lifespan. I hope this would sort of create a separate group of trees that would be able to have an interplay with the regular trees in the system to see what effect it would have. Let's look at that simulation now. For this simulation, I increased the sample size by a lot to make sure I was getting relevant data. For some reason, the types of species that were alive during this simulation changed very little over time. While this is partially due to the changes I made with the code, it still was very slow to the point where it took almost 8 hours to get this footage. However, we can see the prominence of the green species, that is the species I gave the advantage to. Surprisingly, it's taking up increasingly like almost 40% of the screen, even though only 5% has the benefit. The other thing I found weird is that the area which doesn't get the benefit also took a long time to sort of be covered back by the stronger blue species of tree. For some reason, the advantaged green trees dwindle in number. I think this is because as they shift more and more towards having high health and low attack and reproducibility, they become less competitive with the surrounding ones, which means more and more only the ones with the advantage are allowed to survive, whereas the ones that are maybe just in that 6th percentage point just lose to the superior blue trees. Just like the previous simulation, we can sort of see the main group of trees in the graph shifting upwards and to the left, increasing their attack and decreasing their reproducibility. However, it's much slower than the incentivized growth of the green trees. Even though the initial point of these videos was to simulate evolution, I think what I might do is just create more different species so that they start sort of fighting each other in the simulation. I think that'll be really fun to watch. Thanks for watching. If you have any ideas for the simulation, I'd love to try and implement them, so just comment below.